Alpha diversity is analysis of diversity within samples. So it can be a representative of the number of species and the evenness of species that are present in the sample. It can be both rich and even, which means that there are a lot of species and they're in equal amounts. It could be rich but not even, so it would have a large amount of species, but they're not equally present. Or it could be neither rich nor even, in which there aren't very many different kinds of species and therefore they're not equally balanced.
Alpha diversity values can be compared between groups, which is something you may look at for your project. In our code today, we're going to be comparing inflamed and non-inflamed samples, but you might be able to categorize by country or any other variables you would like to investigate.
There are several different kinds of alpha diversity metrics.
The first is the observed species metric, which is just the number of OTUs found within the sample.
Another metric is the Shannon index, which looks at both the abundance and the evenness in the sample.
A third metric is the Chow-1 estimator, which is a measurement of richness that takes into account rare OTUs in the sample.
The phylogenetic distance metric is a sum of the length of all of the phylogenetic branches for each OTU.
And the final metric is the Simpson index, which is a similarity measure. The higher the value of the index, the lower the diversity of the sample.
So to code for your alpha diversity, you're going to start in QIIME and terminal, which this produces an alpha diversity text file with the measurements of all metrics.
Then you're going to use RStudio to create a box plot of your specific metric you want to look at and compare the groups and covariates. Alright, so we're going to start by using terminal, and I've logged into MSI, logged into the lab, and loaded QIIME.
So the first part of the code is an alpha diversity Python script.
And the -I sets your input file, which is our filteredgevers.biome file, which is found in my personal file in the Biology 3004.
The -O represents the output file, which is where we're going to end up putting our diversity metric file. And this is it's going to be a text file that's stored in that same place.
The -M stands for the metrics we'd like to look at, so we're going to be analyzing Shannon, Simpson, Chow-1, and the whole tree phylogenetic distance.
The -T represents which tree we're comparing it to, which is the 97 OTUs tree stored in the Biology 3004 shared.
Alright, so after we've created our alpha diversity table in terminal, we're going to load it into R to analyze it. And we're starting by setting the working directory, which is my Biology 3004 file.
Our next step is to load the mapping file. And so we've stored it as a vector called map, and we're using the read.table command to load the file from Moodle into RStudio.
Then we're going to load the alpha diversity table we just created using the read.table command and storing it as alpha.
We're creating a vector called keep_stat, which contains the words inflamed and non-inflamed. These are the two covariates that we're looking at when we want to analyze alpha diversity in our project.
So then we're going to create another vector called keep_samples, which is only keeping the disease statuses, which is the map disease stat, that are found in the keep_stat vector.
The merge_table is the subset of the mapping file with the values that are contained in that keep samples vector that we had just created, so the inflamed and non-inflamed.
So IDs keep creates a vector intersecting the row names of the alpha diversity table and the merge table, which are just the sample IDs.
So the merge table command next is just relabeling that merge table command from earlier to include only the values from the IDs keep.
Then we're going to do the same thing with alpha. We are resaving the alpha diversity file to only keep those found in IDs keep.
Cov1 is creating a vector that contains the disease stats.
And the div metric tells R which metric for alpha diversity we'd like to use, and it stores it as a vector. So we are going to be looking at Shannon.
Both of these vectors will be used later when we're creating a box plot.
And so then the next set is we're getting ready to set up our box plot, and we're setting the margins, the locations of the axis labels, the tick labels, and the tick marks where everything should go.
The next command creates a box plot using the alpha diversity metric that we've created as the dependent variable and the merge table covariate 1 that we created earlier as the independent variable.
So then we're going to be labeling our y-axis as alpha diversity Shannon because we're looking at the Shannon index, and then we're labeling our x-axis as inflammation status, which is the covariate we're looking at.
So this is the results of our box plot. We then wanted to see whether the means between each covariate, the inflamed and the non-inflamed, were statistically different, so we decided to run a t-test. To do this, we created a vector called t-results, which just contains the results of our t-test, and we wanted to do that so it's easier to find the output. And so we're doing a t-test that compares the alpha diversity metric, the Shannon index, on the dependent variable with the merge table covariate 1, which is our information status.
Then to see the results of our t-test, we're going to look at the p-value, which gives us a value of 0.64. And since that's a good difference from 0.05, we know that the results were not statistically significant, and there is no real difference between the means of the alpha diversity of the inflamed and non-inflamed samples.
We hope this video was helpful for you.
Good luck analyzing alpha diversity in your own future projects.
Thanks for watching.